My name is Thomas, and I'm the crazy guy who develops a programming language. The language is called Seed7. It's interpreted or compiled. You can find it in the internet. Just Google for Seed7. There's homepage, a lot of information. And I skipped some slides because I showed them the last time. Seed7 focuses on readability, maintainability. It's statically typed and memory safe, but it is not only a language, it's also a platform. So there are a lot of driver libraries, and therefore Seed7 programs are automatically portable. So no porting effort necessary. And code can be executed at compile time and runtime. This is also an advantage. What Seed7 does not have is a preprocessor. It does not have macros, manual memory management, pointers, and null. So this is all missing. And regarding integers, I have the point. My point is one size fits all. So Seed7 integers are 64-bit signed always, and you see other languages have plenty of integers of different sizes. Maybe you've heard there is an integer overflow. So if we store on the hardware level, integers are stored in fixed size memory cells, 32 or 64 bits, for example. And if you do a computation and the result does not fit, you have an integer overflow. And interesting, what happens then? And the interesting thing is most languages just ignore it. So you get just the lower bits, the higher bits are lost, so you get wrong results without any indication that they are wrong. And you see there are many languages, famous languages, widely used languages, and also new languages which just ignore this problem. And how does it surface? So if you do some computation with very big numbers, like here this multiplication, you see if the result becomes too big, you get a negative number instead of a positive result. And in Seed7 you get an exception called overflow error. So you get the right result or an exception. Of course, sometimes you want to compute with bigger numbers. So in Seed7 there are also big integers, like also in Java. But in Seed7 you can have operator overloading. So you see this expression here. I cannot move the mouse here. Here is the mouse. Okay, this expression on the right side is quite simple compared to how you need to write it in Java. And of course there are strings. So in Java there are mutable and unmutable strings. Other languages like C++ have strings with bytes or strings with white characters. And of course there is in Rust there's the meme. They have so many strings, and it becomes complicated. In Seed7 is just one string type. This is UTF-32, and it can store any Unicode code point, and it can also be used to store binary data. So it's a universal type of string. And if you program, for example, you want to read single key presses. As it turns out, if you use some normal language, you rely on the operating system, on some libraries from the operating system, and you have to distinguish on which operating system you are, if you are in the console or in a window or even in the browser. And here are the functions you need to do that. So you cannot use the same code everywhere, but in Seed7 you can. There's a file named keyboard, and you can always read a character from the keyboard, and that's it. So this is done by drivers. Seed7 has not only drivers for the keyboard, there are also drivers for database, graphics, sockets, file system, console, and so on. And the result is, if you execute the same program as native or in the browser or on the Windows or Linux, whatever, it always looks the same and works the same. So you might be interested in how Seed7 code looks like. So all declarations in Seed7 uses similar syntax. They always introduced with a keyword, then a type, then a colon, then the name, the keyword is, and initialization value. As you can see here, so a variable declaration, constant declaration, type declaration, procedure declaration, all these declarations follow under this concept. And here is a comparison of declarations in different programming languages. You see, okay, in C++, in Java, well, in Java there is no type def, and both have no abstract data type. You may ask, what is an abstract data type? So arrays, for example, or hashes are abstract data types. In Seed7, so in other languages, they are just predefined and hard-coded often. Here in Seed7, they are defined as functions which return a type. So here at the bottom, you see how arrays and hashes and sets are defined in the Seed7 libraries. So an array gets a base type and creates a new type from it. And this is returned by this function. Templates. Many languages have templates, and you have probably seen the angle brackets of templates. So in C++, you write it this way with these angle brackets. Seed7 has a different approach. In Seed7, as I said, code can be executed at compile time or at runtime. And here, for this Seed7 template, we just use this feature. So we declare this function, declare min-max, which has a type as parameter, type t, and it contains declaration for the min and max functions. And of course, in this case, we need to instantiate the template. So this is, in this way, Seed7 is more explicit than in C++ or other languages. So you invoke, declare min-max for integer, big integer, float, and so on. And afterwards, you can use the functions min and max for these types. There are also parameters in Seed7. Normally, you probably know there are values and reference parameters. Seed7 has them as well. And but in most cases, people don't care. Just some value goes into the function. Therefore, in Seed7 there is the in parameter, and in parameter can be a reference or a value parameter depending on the type. So the type defines what an in parameter is and how it works. So normally you don't need to care about it. You just say in string, in integer, in something else, and the type has already decided what to do. If you want to overrule it, no problem. You can explicitly write var or ref, and then you have a reference parameter for an integer if you want. And of course, there are also these parameters, value, reference, and in, cannot be changed in the function. They are just like constants. And sometimes you want to change a parameter, and therefore Seed7 offers two possibilities. One, the first possibility, in var, allows that you change the parameter in the function, but it has no outside effect. So it's called by value. You get a copy of the value, and then you can change this copy of the value in the function. And but the outside world does not know about it. And the other one is in-out. So you get a reference to the value which comes from outside, and every change you do has an effect outside. Let's start with some little example. Here I have a block which is similar to a try-catch. So we have some statement here where integer is divided. So diff is the division operator for integer. There is not a slash used, but a diff. And if a division by 0 occurs, you get exception named numeric error. So of course you can if you want to try if several divisions of some numbers trigger the exception, you can repeat this code, but who does? Smarter way is we put the code in a function. So this function declares this kind does raise as an integer parameter number, and it just in the middle you see outcome becomes 256 divided by number. So if you call the function, it checks if does raise by 0 or does raise by 1. This is at the bottom. But of course, in this case, we just check the diff operator. And if we want to check more, we can be smarter. Here, we put the expression as parameter. So before, we just get an integer as parameter. This time, we get an expression. So expression is like a lambda where all the parameters are already fulfilled. So like an if condition in a statement is an expression. And here the test expression goes in, and in the middle where the gray place is, this test expression is executed. And at the bottom you see how this is called. So we can check if 256 divided by 0 or 2 to the power of -1 if one of these raises the numeric error exception. But now we are still confined to integer expression. So we can check if some integer expression is this, raises the expression. But we can be smarter, and we put the whole thing into a template. So now the template provides a type, and in the template we declare this as does raise as before, but with the type which comes from outside. So, and if we use this, we instantiate this template with integer and big integers, and afterwards we can just check if does raise for integer division or big integer division, or if the power for an integer or for big integer does raise this exception. Well, there are many libraries written in Seed7, so these are all things that are written in Seed7, in pure Seed7, so you don't need some C or Java library to do gzip or some compression or some graphics like JPEG. So now to the demo. I just need the mouse. Okay, the mouse is here. Ah, now I have it. Okay, sorry. So let's use this. Full screen. And we need the browser as well. So, this is normal Firefox browser, and I've prepared here. One moment. This is not something I expected here. I have to start here a program. Okay. Now can browser, and well, Seed7 can be compiled to machine code, and it can be compiled to WebAssembly, so it runs in the browser. And this is a program I compiled to WebAssembly, and it runs in the browser now. This is just some demo program, some simulation. So this is the green dots are fish, and the blue dots are sharks. And the fish eat something you don't see, and the sharks eat fish. And this is how it evolves. And what I can do now is I can just say, okay, oops, this is wrong. I have just to adjust to, so make this small. Now you can see both. So this is the right one is running in the browser, and the left one is running natively.
Kannst du die beiden Bildschirme ein bisschen nach links schieben?
So now the same program can run in the browser natively. So far, so good. I will stop then. Here. This is my next demo. It comes in the wrong window. Okay. So I started PV7, which is some program to display pictures written in Seed7 and using all these Seed7 libraries, and here it displays a GIF. It can also display TIFF, PPM, icon, PNG, BMP, and JPEG. And the program is 300 lines of code, so it's not very complicated, but it provides here resizing and zooming. So, this is another demo. I have written a program for database access. So I will just need to, where's the mouse again? Here. Okay. Okay, Sampler is the name of the database. So I can say here, this is SQLite, and here's Sampler. And now it opens the database, and here the. So to explain a little bit how this works, it's the program starts the browser, so it accesses the browser and tells the browser, please go to this port, and then it plays web server itself. So now there is a communication between the browser, which does the user interface, and the program in the background, which goes to the database. So in this case, we looked up here this stuff. So the next, and there's also, I know to show what I plan to show. 1 moment. I plan to do some live coding, and therefore, because of the reboot, something got more complicated. Where's the mouse again? Okay, the mouse was here in the edge. I cannot see it. Ah. Okay, here's, sorry. So this is the home page of Seed7. I do some benchmarks here comparing different programming languages. And you see, of course, I made it this way that Seed7 is one of the fastest, and integrated languages like Python belong to the slowest. And one of these benchmarks is the sieve of Eratosthenes. So this is old ancient Greek, how to compute prime numbers. And here is the code example, how Seed7 does this. So I copy, and I now need the editor again. And no, this is not what I want. Undo. When I tested it, this was quite simple to do. But in practice, it's not so simple. Okay, hopefully we succeed now. Yeah, we have it.
Can you make it bigger?
Yes, of course. I just want to save it now. And I make it bigger. No, not this way. But maybe optional 74 font. So, okay, better? So this is the sieve of Eratosthenes, and what we do now, I want to do this not full screen here so I can switch more easily. Okay, now I execute exactly this program in the interpreter. You see it takes 0.260 seconds. But we can also compile it. So
Zoom in a little.
huh?
Zoom in a little.
Zoom in.
Zoom in.
Zoom in, make bigger.
Even bigger.
Thank you so much.
Yeah.
So this is minus O. Okay. This is your fault. You said this. What I should zoom. So now the Seed7 compiler compiled it to C and invoked the C compiler. So we have an executable, and now we can time./Eratosthenes. And now it takes 0.019 seconds, so it's a little bit faster than before. And if you look at the source code here, you see here is the function Eratosthenes which computes the stuff. And here it is invoked and assigned to this variable. What we can do is, instead of assigning it here, we assign it, we assign it here, directly to this variable, but it does not need to be a variable. We can use a constant instead, because it's not changed anymore. So we can get rid of this line, and save it. Fine. Save. And we compile again. Okay, this is, there's some error in it. In the line 24. This is 24. Set of integers, Sieve is, I can.
Semicolon at the end firm, probably?
Is there a semicolon too much? No.
No, at the end.
End of the-
In the last line.
Ah, here. There should be some. Maybe this is, maybe. We will see.
See, the people understand your language already.
So,
Is that your first 20 customers?
No, I have already customers. So, I've compiled it again and we run it and it now takes 0.001 second because we computed all these prime numbers from 1 to 10 million at compile time. So the only thing we did at runtime is just counting how many prime numbers are in the set we compiled at the, we computed at the compile time. Well, how many time is left?
Yeah, not so much actually.
Not so much,
Yeah.
okay.
I think
Because
it
if we-
was about, I think, 20, a bit more than 20 minutes.
Okay, I just want to, where's the mouse again? Ah, here, okay. So I'm just at the last things, I just want to, here and slideshow, start with current slide. So this is the size of the project. So you have a lot of C files and a lot of Seed7 files and libraries, 630,000 in total. These are the downloads because I started at SourceForge. So these are just the SourceForge downloads, not the GitHub downloads. So in the last 5 years or so, I'm on GitHub as well. So for the GitHub downloads, I cannot show a map where it is downloaded, but for SourceForge, so it's all in almost every country in the world. And you see the dark green countries are just dominating. And these are the people who contributed. So it's not a one-man show, so I get contributions from everywhere. That's it. Thank you. And we have some questions as well.
Yeah, sure. So we can maybe have like about 5 minutes or so for questions so that every speaker has like his time of speaking here.
What was your motivation to start this?
I want to use it when I program. So I created it for myself. And there are some other aspects in it, like user-defined statements and so on. So I want a powerful tool, and I created it for me.
You really thought that all the programming languages out there are not good enough, so really...
Yes, mine is better, for sure. For sure. So I've enough self-confidence, yes?
How long have you been working on this? How long?
Decades.
When did you start this?
The first ideas are from the beginning of the 80s. So when I was at the university, I looked at other languages and said, okay, it would be nice to have this feature from this language and this feature from that language. So the idea was some general language we can do everything, which of course is not what came out, but this was a goal at that time. Yeah?
Why have you called your language Seed7?
I have some ideas, and I seed my ideas out, and hopefully they will grow, and others will use it.
Okay.
And 7 is just a fancy number it's a
Sounds
a
good.
prime number, and it sounds just good.
Okay.
Seed7, so 2 S's and so on. Yeah.
How do you see like the future of Seed7? How would you like?
Well,
to
in the past I did not push it too much, so I hope more people will use it, because now I'm starting to push it more. So in the past I developed it for my own until 2005. Then I released it, but it was not like, I did not do a lot of announcement, and I have no backing from a company. So it's just like, if a company brings something out, it's like everybody thinks it's good. And if I bring something out, this cannot be good, because it's not a company. Yes?
What's it written in under the hood?
What?
What's it written in under the hood? Like
C.
The C. Okay.
So the interpreter is written in C, and the core libraries, the drivers I talked about, are also written in C. But it can run on every machine where there's a C compiler,
Cool.
basically.
Did
Yeah.
you pre-compile to C? If I understand?
Yes, so my compiler produces C, but it's not a general C, it's a dedicated C for this C compiler in this operating system. So you cannot, so the output of my Seed7 compiler, the C code is not very pretty. It's optimized, it's like, I treat C as portable assembler. So not as something for humans to read.
So you have mentioned that it is executable at the compile time. So how
Yes.
you are achieving it?
Because I have an interpreter. So the interpreter is part of the runtime library. So and what we did is we executed the Seed7 compiler. So the compiler is, in this case, it was an executable. But part of the runtime used by the compiler is the interpreter as well. And this, if some code needs to be executed at compile time, it just does it via the interpreter. So if you do some heavy computations, maybe you will have a slowdown in the computation time because it's interpreted and not compiled. So. Yeah?
From your point of view, what's like the best use case for your language, and which is the worst?
Well, it's the approach is it should be general purpose. So you could use it for everything, but in practice are areas where other languages are more used. So if a company already uses Java everywhere, Seed7 is based on C, so there must be some communications via REST or so, would be doable as well. So I would not say something is not possible, but of course I would not write an operating system in this because of the performance. So checking for integer overflow and checking for you are in an array and not outside, this costs a little bit. And in C they say, okay, we don't care if you're pointing to some garbage, we just continue. And as long as everybody thinks it should be this way, speed over all and not correctness, it cannot compete.
Okay, let's wrap it up. Thank you.
Okay.